Okay, we are going to continue with the homework packet. We are on page 17. It doesn't say page 17 at the bottom, but that's what it would be. And we're going to match these 8 graphs with 8 equations that are given in the book. So you need some sort of scrap paper, and you're going to write number 1. And the first equation says y1, that just means the first equation, equals x squared. So what this means is it's the same exact thing as x times x. This is our factored form, and this is our expanded form. Now, when you're trying to graph this, you need to figure out the 2 times that you get 0. So what do you plug in to that equation to get 0? So what you plug in right here would be 0, and what you plug in right here would also be 0. So our only 0 is 0, 0. And then you want to plug in a point on either side, because this is our symmetry point. So if I plug in 1, 1 squared is 1. If I plug in -1, -1 squared is 1. So I'm going to go back to the grid here. And which of these equations goes through 0, 0, and then 1 giving 1, and negative giving 1? It would be graph C. So my equation in factored form, I'm going to write x squared. In expanded form, I'm going to write, whoops, I have this backwards. X times x. Expanded form is x squared. My x-intercepts, where it crosses the x-axis, is 0. Where it crosses the y-axis is also 0. This parabola opens upward, so it's a minimum vertex. Because it opens up. And the line of symmetry is x equals 0. That's because x equals is the vertical line, and 0 is right here. And so that is my mirror for my mirror image. All right, if you go back to your scrap paper, the second given equation in the book for Chapter 2, Section 5 is 2x times x plus 4. So this is given in factored form. To expand that, we would distribute. So 2x times x is 2x squared. 2x times 4 is 8x. When I'm thinking about my table for the 2 zeros, what makes this parentheses 0 is -4. So if I plug -4 into both of my x's, I get -8 times 0, which is 0. The other 0 is what makes 2x 0, and that's 0. Because 2 times 0 times 0 plus 4 is 0 times 4, which is 0. The easiest way to find that is to make a mini equation. So my first question was, when will x plus 4 equal 0? And if you subtract 4 from both sides, it's at -4. And in my second one, it's when will 2x equal 0? And so if you divide by 2, you get x equals 0. So 0 also gives 0. Since I know my 2 points of symmetry, if I'm thinking about my graph, my vertex, my peak, is directly in the middle. So directly in the middle is right here at -2. So if I plug -2 into the equation, 2 times -2 times -2 plus 4, I get -4, that's what 2 times -2 is, times 2, that's what -2 plus 4 is, and that will give us -8. So that is the y value of my vertex. So we're going to go see if we can match this one up. So again, it crosses at 0 and negative 4. This one crosses at 0 and negative 4. But this one also crosses at 0 and negative 4. So which one looks like it crosses down at 8? And that'd be letter E. So our factored form, which was given, is 2x times x plus 4. Our expanded form is 2x squared plus 8x. Our x-intercept is 0, and negative 4 gives us 0. Our y-intercept is 0. We have a minimum vertex at negative 2, negative 8. It opens upward, and the line of symmetry is at x equals negative 2. That's the vertical line. That's a mirror image where you could fold this thing over, and it's a perfect mirror image. Lines up exactly. All right, our next equation given in the book is x plus 2 times x plus 3. So this is factored form because of the parentheses. Expanded form is when we do that double distribution, that FOIL method. So x times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. We need to put our like terms together. So our final expanded form is x squared plus 5x plus 6. So when you make your table, you always want to look at factored form to get your zeros. So our first 0 is what makes x plus 2 equal to 0. And that's at negative 2. So if I plug negative 2 into both x values, I get 0. Negative 2 plus 2 times negative 2 plus 3. That's 0 times 3, which is 0. The other one is x plus 3. When does that give us 0? And that's at negative 3. So negative 3 also gives us 0. Again, if you plug negative 3 into both x values, you get negative 1 times 0, which again is 0. So if you think about what your graph would look like at this point, you have at negative 2 and at negative 3 zeros. So you have symmetry. The vertex is right in between those two. So the vertex is going to be at negative 2.5. To get the answer for what the vertex gives you, the y value, you would plug negative 2.5 in for both x's. So you would get negative 1/2 times positive 1/2, which is negative 1/4. So negative 1/4 or negative 0.25 would be the y value of our vertex. So let's go back and see which graph matches with x plus 2, x plus 3. Seems to be this one. So I'm going to go ahead and write the factored form. That's the one with parentheses. And expanded form was x squared plus 5x plus 6. Our x-intercepts are at negative 2 and at negative 3. The y-intercept. Now, we haven't done that for this yet. This number is always the y-intercept, because if you plug 0 in for x, the question is, what do you get for y? And you would get 6, because you would get 0 squared plus 5 times 0 plus 6. And that gives you 6. So you can always find the y-intercept that way. This vertex is a minimum because it opens upward. And the vertex we found as negative 2.5, negative 1/4. And the line of symmetry is at negative 2.5. The next equation in your book is x plus 3 times x plus 3. So that's factored form. If you want to expand this, because that's the next question, you get x squared plus 3x plus another 3x plus 9. So that simplifies to x squared plus 6x plus 9. That's your expanded form. So we gotta make a table, figure out our two zeros. What makes x plus 3 equal to 0? That would be at negative 3. So negative 3 is going to give us 0. If you want to check to make sure, when you plug negative 3 into both of your x's, you get 0 times 0, which is 0. Now, negative 3 is the only one that gives you 0 because the second parentheses is the same. So this is also our vertex, which is our line of symmetry. So now we're going to plug in a point on either side. Let's do negative 2 and negative 4. This should give us the same answer. So negative 2 plus 3 times negative 2 plus 3 is 1 times 1, which is 1. So both of these give you 1. All right, so another point we could plug in would be like negative 1 and negative 5. That would match up. So if you plug negative 1 in, negative 1 plus 3 times negative 1 plus 3 is 2 times 2, which is 4. Probably the easiest point to plug in is 0, and this is good also because that's going to be our y-intercept. So 0 plus 3 times 0 plus 3 is 3 times 3, which is 9. You don't have to plug all of these in for your x and y, but you can if you so desire. Okay, so let's go see which one crosses only at negative 3, and that would be graph F. Whoops, right there. That's negative 3. So, x plus 3 times x plus 3. X squared plus 6x plus 9 is expanded form. Our only x-intercept was at negative 3. Our y-intercept, we found that 0 gave us 9. If you didn't know that, you could look up here to the expanded form and see that 9 is the only number. So if you plug 0 in, you get 9. This is the minimum vertex, and the vertex is at negative 3. And it does open up because, again, it's positive. And the line of symmetry is that line that you draw. That's a perfect mirror image. So that would be at negative 3 because that's the x value of the vertex. On to our fifth equation. That is expanded form. This is like we did at the beginning of the book. It's kind of like that L times 4 minus L, because you could use any number. So if we expand this out, we get 4x minus x squared. That minus tells us our parabola goes like that. So if we look back at our factored form, our two zeros, there's an x alone, so that means that 0 gives us 0. And then 4 minus x. If I add x to both sides, I get 4 equals 0. So 4 gives me 0 as well. Since I have symmetry, my line of symmetry is the number directly in the middle. If I plug that in, 2 times 4 minus 2 is 2 times 2, which is 4. So we're going to go back and see which one is an arc. And there's only one that's an arc. That's letter B. So we have x times 4 minus x expanded would be 4x minus x squared. X-intercepts are at 0 and at 4. Y-intercept is at 0. This vertex is a maximum because it's an arc, and when we plugged 2 in, that symmetrical line, we got 4. It does open down, and the line of symmetry is at 2. Again, the line of symmetry is this vertical line that we can draw that if you fold that parabola over it, that mirror, it directly lines up. All right, we have 8 total. 3 more. So in your book, the 6th equation is x times x minus 4. If we expand that out, we get x squared minus 4x. For the table, our 2 zeros are at 0. And then what makes x minus 4 equal to 0? That's 4. We have symmetry. The point directly in the middle is 2. When you plug 2 in, you're going to get 2 times 2 minus 4, and that's 2 times negative 2, which is negative 4. So we want to see which one goes through 0 and 4, and that is h. So x times x minus 4. So our x-intercepts are at 0 and at 4. Y-intercept is at 0, where it crosses the y-axis. This is a minimum again because it opens up. And the line of symmetry, 2 is directly in the middle. Our vertex, again, was 2, negative 8. The 7th equation, x times x plus 4. If you FOIL or distribute that out, you get x squared plus 4x. If you look at your table, what makes an x alone 0 is always 0. What makes x plus 4 equal to 0? That would be negative 4. So negative 4 gives you 0. We have our symmetry. Negative 2 is directly in the middle. If you plug negative 2 in for both of your x's, you get negative 2 times 2, which is negative 4. This one again should open up. It's a positive x squared. So we're looking for something that crosses at 0 and at negative 4. That would be graph A. So x times x plus 4. X squared plus 4x. X-intercepts are at 0 and negative 4. Y-intercept is at 0. It's a minimum vertex. The vertex is a minimum. It's at negative 2, 4. It opens up, and the line of symmetry is at negative 2. For our last equation, we have x plus 3 times x minus 3. Our expanded form is x squared minus 3x plus 3x minus 9. If you put these two together, you have x squared plus 0 minus 9. If you think about your table, when does x plus 3 equal 0? That's at negative 3. So negative 3 gives us 0. When does x minus 3 equal 0? That's at positive 3. So 3 gives you 0. What's directly in the middle is 0. If we plug 0 into the equation, we get positive 3 times negative 3, which is negative 9. So our last one to match up is graph 7. Our x-intercepts are at positive 3 and negative 3. Y-intercept is at negative 9. This is again a minimum point. Opens up. And the line of symmetry is at 0. All right, we're going to do one last thing, and that is figuring out which equations are quadratic and which are not. So we're going to turn to your book on page 30. We're going to do 31 through 39 together. Homework is number 40 and 44 through 48. So the question is, on page 30, which of these equations are quadratic and which are not? And 31, I guess, actually starts on page 32. The homework section starts on page 30. So 31 is 5x plus x squared. This is quadratic because you have an x squared. It's an expanded form. 32 is 2x plus 8. If you want to pause and answer it, you can do that right now. This is not quadratic. This is a line because it's in y equals mx plus b form. 33 says 9 minus x times x. This is quadratic. It's in factored form. If we expanded that, we would get 9x minus x squared, so we know it's going to give us an arc. 34. This is quadratic. This is in factored form. If we expand that, we would get 12x plus 4x squared. 35. Y equals 3 to the x. Do you remember the last book called Growing, Growing, Growing? Y equals starting amount times constant multiple to the x power. So this is exponential. This is not quadratic. 36 is x squared plus 10x. That is quadratic. It's an expanded form. 37 is x times x plus 4. That is quadratic. If you want to FOIL that out or factor it out, you'd get x squared plus 4x. 38. Looks like we can distribute that. That would give us 2x plus 8. That is not quadratic. That's a line. You have to have an x squared in expanded form to have a quadratic. So that's in the form y equals mx plus b. And the last one. We do have an x squared. It would be best to look at that in proper order with the biggest x exponent first, going down in order. This is quadratic, and it is an expanded form. We could factor that if you desire. Two numbers that multiply to give you 10, that add to give you 7, 5 and 2. So these two equations are the same. All right, you're going to go ahead and work on your homework. If you finish that, come on up and get a worksheet to work on next.